We're going to talk about how to solve rational equations now. So here we have an example, 1/3 minus 5x, 6 is equal to 1 over x. And we're going to do it in a slightly more complicated way than is strictly necessary, just so we can take that method and adapt it to other more difficult problems. So what we want to look at is we want to get a common multiple, the least common denominator among all of our denominators here. So our three denominators are 3, 6, and x. Now 3 doesn't break down anymore, but 6 factors nicely as 2 times 3, and x doesn't break down any more than that. So when we want to find the least common multiple, we look at all of the factors and we take the largest power of each. Okay, so we will take the 3, the 2, and the x, and when we multiply those things together, we get our least common multiple of 6x. Okay. Once we have this least common denominator, we want to multiply both sides of the equation by it. So when we multiply over here, we could distribute if we like. So we get 6x over 3 minus 30x over 6 is equal to 6x over x. And over here, we'll get 2x, and then we'll get minus 5x. And then we're going to cancel the x's here. We're just going to have to be careful at the end. And I'll get back to that in a second. So if we subtract these two combining like terms, we get negative 3x equals 6. So to get x by itself, we get x equals negative 2. Now, whenever you do solve a rational equation, you want to go back in and check your answer so you make sure you're not dividing by 0 anywhere when you actually plug x in. And that's what I mean by we have to be careful when we cancel these x's here. So if x equals negative 2, if we plug that in, the only place that's going to appear is here. Negative 1 over negative 2 is fine. We're not dividing by 0. So this is a valid solution to this problem. So let's go ahead and look at another problem. So let's say we've got 3 over x plus 2 plus 2 over x plus, or is equal to 4x minus 4 divided by x squared minus 4. Okay. So again, we want to find the least common multiple of these things. So we look at the denominators, and they're x plus 2, x, and x squared minus 4. Now, x plus 2 can't get broken down into any more factors. X can't get broken down into any more factors. X squared minus 4 can. This factors is x plus 2, x minus 2. Okay. So now we're going to look at that and take the the highest power of each one of these different factors. So we're going to take x plus 2. We're going to take x. We've already taken our x plus 2 from up there, so we will also take this x minus 2. And so our least common divisor that we would have is x plus 2 times x minus 2. And I'm going to leave it written that way. We could FOIL it out, but we're going to leave it that way because it's going to make the cancellation we're going to have to do a little bit nicer in a second. So what we're going to do is take this expression and multiply both sides of the equation by it. So we have x plus 2 times x minus 2 times 3 x plus 2 plus 2 over x equals 4x minus 4 over x squared minus 4. And we will write this out over here. X times x plus 2 times x minus 4. Okay. So when we FOIL, okay, or distribute this term, we will get a cancellation with the x plus 2 in the first one. So in the first term, we get 3x times x minus 2, because this is going to cancel with that one. But when we distribute this one, the x is going to cancel. So we're going to have 2 times x plus 2 times x minus 2. And on the right, remember that we had x squared minus 4 factored as x plus 2, x minus 2. This should be a 2 over here. That's a mistake on my part. So what we're going to get is actually these two will cancel with the denominator here. So we just get 4x minus 4, that quantity, times x. And now it's a linear or quadratic equation, depending on how things cancel. So we get 3x squared minus 6x plus 2x plus 4. Oh, well, no, we got to FOIL this, so we'll do it in a couple steps here. So this is 2 times x squared minus 4. And this is going to be 4x squared minus 4x. So it's going to be quadratic by the looks of it. So we will get 3x squared minus 6x plus 2x squared minus 8. And since it's quadratic, we want to get everything over to one side. So we'll subtract the 4x squared and add a 4x and set the equation equal to 0. So if we combine like terms here, 3x squared plus 2x squared minus 4x squared, we get x squared. Negative 6x plus 4x is a minus 2x. Minus 8, we get 0. Now this is a nice factorable expression. We get x minus 4, x plus 2 equals 0. So by the looks of it, we get the two answers. X equals 4. And x equals negative 2, just by solving this equation. Now here we have to go back and check our answers. So if we plug 4 in, this denominator is a 6, no problems there. Denominator is a 4, no problem there. X squared, so 4 squared is 16, minus 4 is 12, no problems there. So x4 works, no problem. Now if we plug in x equals negative 2, we're going to have a problem right away because negative 2 plus 2 is 0. So if x equals negative 2, we're going to divide by 0. So this answer is not going to work, and it would also not work on this side of the equation either. So we get one answer only. We get x plus 4 is our solution to this rational